Hello creators! This video is going to demonstrate a sample AP Computer Science Principles task for the 2021 College Board requirements. This video is entirely my own creation. I have not validated my responses or my code with the College Board, but it is my opinion as a teacher of this course for the past 6 years that this task and the written responses I'm about to share could meet all 6 rows of the College Board's new scoring criteria. So here we see the user interface in MIT App Inventor. This is a vision tester app, or at least a simulation of a vision tester. Here on the user interface, we have a tumbling E image, as well as some arrow keys that the user can respond to the app with. So if the E is opening to the right, the user can click the right arrow key. Over on the right side of my screen, we have the emulator up and running. We can dismiss the notifier. We see that our E is opening down, so we can click the down arrow key. We can see that we earned a check mark at the top of our UI. Another down arrow gives us a second check mark. Up arrow gives us a third check mark. This next one is opening to the right, but I'm going to incorrectly click to the left. I see that my results now are showing that error. My app is now disabling all of these arrow buttons. The only button that does work is the reset button. So if I do a long click on the reset, I can reset the tumbling E and I can reset the results label. There is going to be a link to a better demonstration video below in the description of this video, so please feel free to check that out. There will also be some links to different points in this video where I discuss the 6 individual rows for the College Board. So here we go, row 1, program purpose and function. This response is limited to 150 words. You'll see that my responses total 158 words, which is a little bit over and is probably okay, but I haven't confirmed that with the College Board, so do this at your own risk. If you happen to be watching this video late at night and maybe have a blue light filter on, you might want to take a moment to shut that filter off because you should see some yellow highlighting for some keywords and phrases. A blue light filter will certainly hide that highlighting. So here in row 3A, the first prompt asks us to describe the overall purpose of the program. Describe means we need lots and lots of very specific details. So I wrote the overall purpose of the program is to simulate a vision test similar to the tumbling E charts that an optometrist might use to check your eyes. Next prompt again says describe, so we're looking for very specific details. The functionality of the program demonstrated in your video. Again, a better demonstration video of my app's functionality is linked below. The functionality of the program demonstrated in my video begins with a directions notifier. The app then displays a tumbling E in one of 4 random directions, for example, up, down, left, or right. The user then responds to which direction does the E open by clicking the arrow buttons to indicate direction. If they choose correctly, 3 things happen. Number 1, a check mark is earned. Number 2, the E tumbles to a new random direction. And number 3, the E gets smaller. If the user clicks the wrong direction, as I showed a moment ago, a red X appears and the app must be reset. Please notice that is very descriptive and very detailed. We must describe. Our last prompt in this row is to describe the input and output of the program demonstrated in the video. My input includes clicking one of 5 buttons, up, down, left, right, or reset. And my output includes an image of a tumbling or shrinking E, including a check mark for each correct response and a red X for an incorrect response. So again, these 3 responses here total 158 words, which is a bit over the maximum of 150 words for this section. So a little bit of revision is probably needed here. As a teacher, I tend to be wordy, so you can probably see some room for improvement. All right, response 3B. This is in response to row 2 and row 3 in the College Board scoring criteria, data abstraction and managing complexity. We begin by capturing and pasting 2 program code segments. For MIT App Inventor, this is going to be a screenshot of the code. If you're using a text-based language like Java, you can either paste a screenshot or you can paste your actual code. The good news is if you do paste code, that does not count against your word count. So you can see that here I have 0 and 0 for my first 2 responses because they're screenshots, they're code. But then my next 3 responses total 263 words. This is way over the limit, the 200 word limit, I should say. And so I need to stress that this response needs to be carefully revised and abridged. The first program code segment must show how data have been stored in the list. So my data abstraction, my list, stores the 5 buttons on my user interface: button up, button down, button left, button right, and button reset. I happen to include the numbers 1, 2, 3, 4, 5 just to remind people of the index of those buttons. MIT App Inventor uses 1 for the first element, or the index of the first element in a list. The second program's code segment must show how the data in the same list is being used, such as creating new data from the existing data or accessing multiple elements in the list as part of fulfilling the program's purpose. So my app doesn't create any new data. I don't add any data to this list of button elements. My app accesses the data. So when it accesses the existing data, it uses a when any button click event handler. And when that button is clicked, it finds out the index of that button, 1, 2, 3, 4, 5, and then it will end up passing the index of that element of that button component to a procedure, a student-developed procedure, or in this case, a teacher-developed procedure that you will see in a moment. And it also passes a Boolean argument false that determines whether we should reset the app or not. Our third prompt asks us to identify. Please understand that the word identify is different than the word describe. So if somebody said, please identify your child, I have 3 kids, I could just point to them, I could say their name. If somebody asked me to describe my 3 children, I would speak in a lot more detail. So this says identifies the name of the list being used. So I simply say the name of the list being used is arrow buttons list. Now we have that very important keyword describes, what the data contained in the list represent in your program. So I responded, the arrow buttons list contains a list of 5 button components on the app's user interface: button 1 up, button 2 down, button 3 left, button 4 right, and button 5 reset. Please notice how specific I'm being here. When the College Board reader reads this response or a response like this, I don't want them to be guessing. I want them to know that I know my stuff. This is my app and I've worked really hard at it and I know all of the details and the inner workings of my app. This data represents references to the 5 buttons on the user interface that handle the event-driven input during the vision test. Is the tumbling E opening up, down, left, or right? So it's very clear that I'm connecting my data with what it represents in my program and the user experience. The next prompt asks me to explain. So much like a describe, I need to include lots and lots of detail. This is perhaps one of the most challenging prompts of the new College Board's requirements for the create task, so please be careful here. We need to explain how the selected list manages complexity in your program code by explaining why your program code could not be written or how it would be written differently if you did not use the list. In my professional opinion, it's rather difficult for new programming students to explain why your program code could not be written. Most new programmers do not have enough experience to claim that a program could not be written without a list, although it might be true. So I would recommend the safest approach here is for you to explain how your program code would be written differently. And almost always that means without a list, it's going to be much more cumbersome, much more laborious to write, much more complex. So my response is, this app would be written differently if I did not use the list named arrow buttons list. However, that code would be much more complex. Without the arrow buttons list, the single when any button click event handler would need to be replaced with at least 5 and maybe more separate event handlers. So here I'm making a very clear case about how it would be more complex without the list. I go on to say, and calls to the student named procedure, one to handle each button. So I would have to have more event handlers and more calls. That would be more complex. Additionally, without the arrow buttons list, the student name procedure would probably need a long and complex chain of if-else-if statements to handle the different user inputs. Since I'm trying to make an argument or I'm trying to explain, I now show the other side of this perspective. Instead, the arrow buttons list manages complexity in the program by abstracting each user input as a single number. So the index of the respective button element, up equals 1, down equals 2, etc. And that data can be more easily passed as a parameter and processed by the student named procedure. Additionally, future versions of this app can easily be refactored to include fewer buttons. So for example, if I had a young user of the app, maybe 3 or 4 years old, maybe I only want 2 buttons. I want a left and right button. Or maybe I want more buttons. So maybe I want to allow 8 buttons instead of 4 that are incremented in 45-degree increments. And here is a very strong closing argument. To create these versions, the programmer would only need to update the user interface and the elements in the list. No other changes to the code would be required. This is the power of abstraction, and this is the power of a list, at least a properly implemented list. All right, response 3C. This corresponds to row 4, procedural abstraction, and row 5, algorithm implementation. Again, this has multiple parts. You'll see that a couple of these parts have code segments which do not count towards your word count, but we do have a couple parts that are a bit wordy here. My current total is 253 words, 53 words over the 200-word limit. This response definitely needs to be carefully revised and abridged to meet that 200-word limit. You'll see here some of the yellow highlighted key phrases and words that you'll want to include in your response. Here is a peek at the procedure in my app. I'll pause the video here for a couple seconds. On the top of the procedure, this top contains if, else if, else statement. I tell my students that at a minimum, they want an if, else if, or an if-else statement, a two-way selection. A single if statement might not be enough to meet the College Board criteria. This particular procedure also has 2 loops when the College Board only requires a minimum of 1. Here's a peek at the bottom of my procedure, again pausing for a couple seconds. Next, we have the second code segment must show where your student-developed procedure is being called in your program. You need a minimum of 1 of these calls. My program happens to have 3 calls. I don't know if I needed all 3 here, but I did include all 3. I'm pretty sure that 1 of these calls would be plenty and I would score the point, or at least I wouldn't risk not scoring the point with just 1 screenshot of 1 call. Then we again see this describe prompt in general, what the identified procedure does and how it contributes to the overall functionality of the program. So my response is the check responses or reset procedure has 2 parameters. 1, a Boolean should reset app, and 2, an integer response index. This procedure does not return any values. In general, this procedure contributes to the overall functioning of the program by processing the user input, passed via parameter to determine A, if the user's up, down, left, or right button click input matches the direction of the tumbling E image, or if B, the user has clicked the reset button. This procedure displays output on the user interface, for example, if the user input is correct or incorrect, as well as a new e-image, etc. As I've noted several times, my responses in this draft are way too long, and this particular response is probably my best shot in this section of reducing my wordiness. Please note that the prompt says describe, which means I need detail, but it also says in general. So this means I should probably shorten this section up, reducing it by a sentence or two until I'm within the word count. This next section is also a section of concern this year with the College Board's new requirements. And in the past 6 years of teaching this course, I've probably seen most students miss this point due to this next section, so please be careful here. This does say explain, but unlike the previous prompt that said in general, this explanation must be detailed enough for someone else to recreate your entire algorithm. So that's a very tall order. You'll notice here that it says detailed steps. So I happen to think that numbering these steps is a really smart way and an efficient way to make sure that you cover everything in your algorithm from beginning to end. So when my procedure is called, the algorithm implemented by the check responses or reset is, number one, it receives a Boolean argument via the should reset app parameter. Number two, it receives an integer argument via the response index parameter. Please notice that I'm being very detailed here. I'm talking about the type of data, Boolean or integer. I'm also using the keyword argument, so I know that some data is being passed to this procedure and it's being received by the parameters of the procedure. These are wonderful words that are going to warm the hearts of your College Board reader. Number three, if should reset app is true, the size of the tumbling E image is reset to a default 400 pixels by 400 pixels. It happens to be square. The result label is reset, and a loop is used to re-enable all of the user interface buttons. Else, if should reset app is false and the response index is equal to the random index, that means the user has clicked the correct up, down, etc. button, matching the direction of the tumbling E, the app displays a check mark on the user interface. Step 5, else the app displays a red X on the user interface and uses a loop to disable all the buttons except for the reset button. This, of course, is when they click the wrong response, the wrong direction for the E. And then finally, this procedure shrinks the tumbling E by a scale factor of 0.75, gets a new random index, and displays the tumbling E in one of 4 directions corresponding to the random index. I would hope that this description, this very detailed step-by-step description, is detailed enough for someone else to recreate my procedure. So pause here and ask yourself, could you recreate my procedure with these 6 steps? If not, I probably need more detail. Look at your own response. Ask if somebody could recreate your procedure, or better yet, hand your response to a classmate and say, could you recreate a procedure based on these steps? If they can't, we probably need more detail, but do watch the word count. And finally, row 6, testing. Again, this response is over the word limit, 221 words, so it needs to be revised down to about 200 words. I need to describe 2 calls. Again, it says describe, so we're looking for detail. My first call is at 0.14 in the video linked below in the description, not in this video, but in the video linked below. I'm running out of time on this video, so I'm just going to freeze here. You can pause the video and read through my responses for the first call and for the second call. If your calls do not appear in your video, you are welcome to use hypothetical calls or describe situations in which the user would have one call versus another call. So feel free to describe calls that are not in your video. Of course, if your call is in your video, that's a really wonderful correlation between what the College Board scorer sees in the video and what you write about in your responses. Next, we have to describe the conditions being tested. So please notice that conditions are going to be statements that are true or false. You can pause here to check these conditions. And then finally, we need to identify the results of the calls, the first call and the second call, and those results should probably be user-centered, so results that the user can see or user can hear or user can feel tactily through the app. Finally, I just want to remind you about the College Board's policy on plagiarism. Please don't plagiarize anything you see in this video. You'll notice that I used yellow highlighting to highlight keywords. Of course, if you use the same keywords, that's good, but please don't copy this app and please don't copy any of the wording you've seen in my responses or the descriptions I've offered in this narration.